For the next few months, Geyer and Weifenbach spent long hours recording the signals from Sputnik 2, and then in January 1958 from the first U.S. satellite, Explorer 1.
Not that we had any idea whatever of what we would do with it. We didn't. Little by little, Bill, who's a theorist, he got very curious about the orbit of Sputnik, just trying to understand orbital mechanics in the simplest sense.
We were all intrigued with the shifting frequency that we thought initially was maybe a instability in the oscillator, until some of us thought of it must be the Doppler shift.
Though others recognized the significance of orbit determination by Doppler tracking, only Geyer and Weifenbach were able to correctly solve the problem of determining a precise satellite orbit using the Doppler effect.
Frank McClure heard about this. Bill and I had wrote up a report about it. And McClure read the report.
He called us into his office and said, "Close the door." And he very briefly asked us if we thought we could know, if we knew the orbit, could we find the station?
And he challenged us as to whether or not we were diddling, or did we have was what we were doing genuine? And
with a few minutes thinking, we said, "Sure." And then he started outlining what he thought about the importance of navigation.
McClure was now confident that his theory of determining one's position on Earth by calculating the exact position of an Earth-orbiting satellite could now be proven. After a weekend-long brainstorming session, McClure, along with his APL colleague and friend Richard Kirshner, emerged having designed the protocol for an all-weather, 24-hour-a-day satellite navigation system. Transit, now NavSat, as the first Navy navigation satellite system is called, provided a precise navigational reference needed for Polaris submarines to target their missiles against enemy installations. The system was also installed on surface combatant ships. By 1967, just 3 years after Transit became fully operational, it was made available by the United States government for use by civilian ships and to industry for the manufacture of shipboard satellite receiver navigation sets. The privatization and proliferation of navigation sets in the civilian sector has transformed the way transportation systems operate. But satellite navigation has also found its way into use for industrial applications, such as geological studies for offshore oil exploration. With 4 operational and 2 stored-in-orbit satellites remaining, the Navy decided to discontinue global navigational position fixes beyond the end of 1996. This after 32 years of continuous service by the system and almost 4 decades after the invention of satellite navigation.